Now, chapter 9 is cool, Robert, because if you move sequentially through 7, 8, 9, we've oxidized methane to get methanol, and we're going to take one step of an oxidation and talk about
aldehydes.
Aldehydes. Which, technically, the name is methanol, right?
Right.
So let's just do this. Let's start with this. Naming is important. Meth, one carbon. Ane, no double bonds. Methanol. Notice the Al. That will correlate to aldehydes. Any word, if you're taking the national board exam and if they ask something like, I don't know what they're going to ask, but if they say, is this an aldehyde, is it an alcohol, what is this? If it has an Al, odds are it's an aldehyde. Okay, so I guess what we're talking about is chapter 9, right? So chapter 9, we've got our notes here, because Robert just said to me, he's like, what are we actually saying?
I know, I couldn't remember.
Here's our notes. All right, so we talked about naming. I think he's drawn out the formaldehyde molecule, and I think this is a functional group. Aldehydes are a functional group?
Right, which we talked about last chapter. And by the way, methanol is a formal name. Formaldehyde is the common name.
Right, it's a street name.
The street name. That's a good way to look at it.
Do you know where it comes from?
Formaldehyde? Or the name?
The name, formaldehyde.
Yeah, from
ants. The formic acid was
right.
initially found on the back of ants, and it was a single carbon acid, and it was derived from that.
Formic acid.
Yeah.
And this is a reduced form of formic acid.
Because people
from
formaldehyde. The scientific name for ants is formaldehyde.
Okay, well, good.
Yeah, so formaldehyde.
Formaldehyde. Yep.
Okay, cool. All right. So now, what in here causes this thing to function? There's some properties in the formaldehyde molecule.
Well, so formaldehyde, we talked about it earlier, it's polarized. It's got a positive side and a negative side.
Like water was polarized.
Like water is polarized.
Right.
So there's proteins in your body, right? And we'll just make that simple by writing an amine. And when proteins break down, what's happening is they go into the body and formaldehyde reacts with them. So this is a negative part of an amine, and that's a positive part, and this will react with that.
Okay. Yeah, I feel like you kind of jumped way ahead. I'm gonna slow us down a little bit.
Okay.
Is that cool? Okay.
That's cool.
All right. Where's your eraser? Didn't you have a little eraser somewhere? Oh, there it is. Okay, cool. So go ahead. Yeah, leave that up there. Let's get rid of the amine. Cool. Is it amine or amine?
It's an amine.
Amine.
Mm-hmm.
All right. So here's what I'm gonna do is let's just for a real quick second, let's erase the hydrogens and walk me through what I'm now looking at. This is a carbonyl group, right? And what properties does the carbonyl group have and why?
Well, carbonyl groups are polarized. That's an electronegative atom and an electropositive atom.
I'm going to stop you there. Make sure you look at your vocabulary terms and are familiar with electronegativity. The other one I'm really big on is valence. Valence and electronegativity. If you don't have those on lock, go look at them, get them on lock.
Yeah, that's true, yeah. So those are fancy ways of saying the oxygen has is more negative than the carbon. That's really all I'm saying.
Cool.
So this is negative and that's positive.
Okay. Now, what happens is this property will drive essentially the cross-link, the methylene bridge, the embalming reaction. Because as you said, now draw in your amine.
Right.
So
amine? An amine, or however you want to. The bottom line is proteins break down into simpler molecules like amines. And what the aldehyde does is it prevents that breakdown. It grabs onto everything and slows the process down.
And while you're doing this one small step, do look at proteins are made up of polymers or chains of amino acids. So when he says the word amine, he's just saying this is one small part of a protein.
Right, and that's why I drew the letter R. That just means there's a lot of other things there, but this is just, we're focusing on the amine. So when you have an aldehyde, which is in the main ingredient of embalming fluid, it's
one of the primary.
It's one of the primary ones.
Preservatives, yeah.
Preservatives, right? It's a preservative. So as molecules are breaking down, the amine is going to react with the aldehyde.
Because there's charges to
right,
these guys,
because that's negative and that's positive. They're attracted to each other like two ends of a magnet. That's the best way to think of it.
Cool. Okay. So that formaldehyde has a carbonyl, and we're going to see the carbonyl repeat through the next couple chapters.
Yeah.
So now in a bottle, where's your eraser again? Okay. Okay. So in a bottle, we're just going to go back to formaldehyde. This is an important designation. I'm going to erase methanol, and I'm going to erase the charges. In a bottle of embalming fluid, formaldehyde doesn't actually look like this, right? You know, what's interesting is I know a lot of people who have tattoos of formaldehyde on them, and I'm like, it doesn't really look like that. You know, what does it look like in a bottle of embalming fluid?
Well, it's in equilibrium with a few things, but one of the things it's in equilibrium with is just water. So I know it's really fancy, but it's actually in this form quite a bit.
And what do they call this? Methylene glycol.
Methylene glycol.
It's called methylene glycol. It's equilibrium with methylene glycol,
Right.
so this is more likely what you're going to find in a bottle of embalming fluid.
And again, for those out there, this is the main subject, but it's an equilibrium. They both exist at the same time.
At equal portion. But
Equal
you can't
portion.
pick one out over the other. You can't pick one out. Okay?
So
very cool.
It's that.
Yeah, okay. Very cool. Now, what's also important is if you have a bottle of embalming fluid, most embalming chemicals, and I've looked through all of them, right? I've looked at the SDS, they always have methanol in them. They always have alcohol in them. What the methanol does is it stabilizes formaldehyde, extends the shelf life.
Right.
Because over time what will happen is this will start to break down and it precipitates. It falls out of solution in the embalming.
So yeah, what the methanol does is it kind of prevents that reaction. It ultimately prevents reaction with water. And this right here, if you leave that around, it'll further react to paraformaldehyde, which is that white solid in the bottles that you see. So this can further go down to paraformaldehyde.
He's just going to write, because it's a long chain that's really hard to draw out.
We don't need to draw it out.
We don't need to draw it out. Maybe we should, maybe not.
It's in the book, right?
It's in the book. It's in the book, yeah.
So you go formaldehyde,
methylene
glycol, and then paraformaldehyde.
Paraformaldehyde.
Okay.
Now, you know this, of course, but cameraman, you don't know this.
He doesn't know it.
Unnamed cameraman. He's not. He's saying no.
I know.
Okay. Paraformaldehyde is actually used in the embalming process. Hopefully, you know this out there. Just to reiterate, and this is everybody. This is strictly for cameraman. Cameraman. Paraformaldehyde is actually used because it's concentrated aldehyde. It's used to desiccate tissue. Used in autopsies. They'll put it in the cavities. It helps dry out, preserve, and disinfect tissues. So you get all these uses out of the one formaldehyde molecule.
Right.
Okay. Very awesome. Now, other aldehydes that are used in the embalming process are things like glutaraldehyde.
Right.
Glutaraldehyde. This is pretty much in the textbook. It has a 5-carbon chain.
Right.
So it's heavier. It's slightly heavier than formaldehyde. So it stays. I think it's well known formaldehyde is a vapor at room temperature.
True. A dangerous vapor, by the way, too. Yes.
Yeah, but we have ventilation and we work safely. Yeah. But glutaraldehyde's a little bit bigger. It has 5 carbons as opposed to that single carbon. It stays a liquid at room temperature.
So, do you want me to? I'll draw that one.
You can. I mean, it's not that. I mean.
1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon.
There you go. And look at this.
So there's an aldehyde here. And aldehyde.
All right, can you see that?
There.
We got that. Okay. Now this is really cool. I'm glad you took the time to draw that because you'll notice that the aldehydes are sitting at the ends of the molecule, right? There's not an aldehyde in the middle. They're sitting at the ends. We call them terminal.
Yep.
They're terminal functional groups, right? Now, if you had this, and I have this eraser here, what I'm going to do, Robert, is I'm going to erase the aldehydes, all these, and we're going to erase these. We still have this 5-carbon molecule, and I'm going to take your pen, and I'm going to draw a carbonyl here, right? It's very similar functional group to an aldehyde,
it is, yeah.
But now it's on a central carbon. What is that called?
That's a ketone.
It's a ketone, right?
Yep.
Yeah, it's a ketone. And it's important because it comes up in this chapter, A, B, but B, C, I guess, is that these are found in the prep room as well. You find these in things like acetone, nail polish remover. So you find aldehydes and ketones in the prep room. The different structurally, they have very different properties. It's always amazing to me how some minor change creates a completely different property, right?
Yeah.
Yeah, this does not preserve.
Yeah, it's not a preservative at
Not
all.
a preservative.
But it is used as it is used in the funeral home as a disinfectant. There is some things that use it for a cleaning solution.
It says it's a solvent. It's a solvent, not a disinfectant, a solvent.
Yeah.
And it's used for things like, nail polish remover, things like that, right? Yeah. Okay, cool. I think that's chapter 9. I think it is, yeah. I think it's chapter 9. That's all the notes we wrote down last night, right before we did this. So I guess if you have anything that we didn't cover, you have a question about, I know that we moved kind of quickly. Add them to the comments section. Keep the discussion going. Chemistry is kind of cool. I always think of chemistry as and science as discovery and dissemination. That's what that's what I like about science. Yeah. But sometimes Robert's he has said to me that chemistry is a conversation, which I don't know if I buy it. Have you ever said that?
I always think chemistry is, if you're a curious person, you can do chemistry.
Right, yeah, but that's not saying it's a conversation, right? Well, but let's continue the conversation. Get comments into the comment section.
Yeah.
Wow. Any questions? And then let us know if this is helping. If not, give us your mnemonics that maybe you have. follow, and yeah.
Comment, and we will respond.
Yeah.
Mhm.